Hello, my name is Aida Nadira binti Muhammad Noor and my matric number is AE1700 and 66. Okay, my title for final year project is Forecasting Power Output of Solar Photovoltaic System using Artificial Neural Network, and my supervisor is TS Dr. Sheikh Zahrul Islam. Okay, these are the content of my presentation. So there is introduction, literature review, methodology, discussion and result, and lastly conclusion. Okay, firstly for the introduction. So introduction of artificial neural network. Artificial neural network is a computing system designed to simulate the way the human brain analyzes and process information. It has self-learning capabilities and allowing them to produce a better result when the more data is available. So for the problem statement, firstly, the output of photovoltaic system is difficult to control due to natural resources from the sun, and secondly, it was difficult to knowing the power output of PV panel system. Okay, next, the objective of my project. So firstly, it was to develop a ANN model that can perform photovoltaic power generating forecasting, and secondly is to predict the power output of PV system based on actual historical measurement result of the photovoltaic power generation system at a specific building. So for the scope of the project, firstly is to develop a ANN model. So the model was separated into two models. First model is to predict the solar radiation, and the second model is to obtaining the voltage and the current output of the PV panel. And then secondly is the prediction of PV output. Firstly, it was to forecast the performance of PV in terms of power by using environmental variable, and secondly, in the ANN model, mathematical equations are used to express the relationship between the output and the goals. Okay, next is for the literature review. So these are the related research with my research. Okay, firstly is from the Valerio Lobrano at years 2013. So the title for his article is the Artificial Neural Network to Predict the Power Output of PV Panel System. So for the observation, it was a network architecture have been tested in order to estimate the power generated by the PV model under actual condition, and the data used to train the network is acquired using two different types of photovoltaic modules connected to the calibrated electrical load. And then the climate variable are obtained through the weather station, and the performance evaluation of the artificial network has been obtained. So this is how he used the artificial neural network to predict the power output of PV panel. So next is at year 2019, and the title of the research the title of the article is the Solar Radiation Estimation Methods Using ANN and Empirical Model. The applicability of the Hargreaves method, the artificial neural network, and the multilinear regression method for estimating solar radiation was evaluated using the daily meteorological data from two stations in northern Greece. The comparison have been made, and then they analyze it. So I made it as the main of my project. And then next is the methodology. So these are the flowchart of overall project. So firstly, it will start, and then the data collection from methodology department, such as the environmental temperature, relative humidity, wind speed, solar radiation, and then next is to develop the ANN, and then the data was divided into 3 sets, and then next is the set the primary weight and the bias. This is set the input for the ANN, and then configure the network parameter, and then analyze the output and compute the error. And then this is for the process of the ANN model 2, and then we update the new input and then calculate the error. Either the error is less than 10%, and then we can proceed with the generate output and analyze result and finding. And if the error is larger than 10%, and then we need to add one neuron, and then we restart from the set the primary weight and bias. Okay, these are the technical flowchart. This is how I will develop the ANN. And then okay, firstly we start and then enter the input data, and then the data was divided into 3, that are the training, validation, and the testing. For the training, he used 70% of the input data, and then for the validation and testing they use only 15%. And then next is the set the number of hidden neuron, and then train the network using the Levenberg-Mark quadrant, and then we train and then we analyze it. If the error are less than 10%, and then we can proceed to get the plot of performance and regression, and then we get the output prediction, and then we analyze the data. And if the error is larger than 10%, and then we need to restart from the process at the start of the hidden neuron, and then you go on with the flow is based on the flowchart. Okay, these are the artificial neural network configuration. So for the ANN model 1, I've used 5 input. That is the ambient temperature, mean temperature, minimum temperature, maximum temperature, relative humidity, and the wind speed. And then I use 8 hidden neuron, and then the target is the solar radiation at the output layer. And then I proceed with the artificial neural network model 2, where I want to predict the current and voltage output. And for the input, I use the temperature, ambient temperature, wind speed, relative humidity, short circuit current, open circuit voltage, cell temperature, and the solar radiation prediction that we have predict from the ANN model 1. And then next is for the result and the discussion. So these are the MSE for the different number of hidden node. As we can see, based on this table, we can see that the number of hidden node at 9, the MSE training are the lowest, and the MSE testing are greater than the MSE training for the 9 hidden node. So the value of R are the same from the first node until the 10 node. Okay, these are the results for the ANN model 1. So these are the configuration of ANN model 1 that I have get from the MATLAB software. And then as we can see, the input, there are 5 input, as I have mentioned at the methodology part, where I am using the mean temperature, maximum temperature, minimum temperature, relative humidity, and the wind speed in order to estimate the solar radiation. So I have used 5 hidden neuron, and then there are only one output at the output layer. So next, these are the graph of the solar radiation based on what I have get from the AM model 1. So from this graph you can see the prediction data are the red line and the actual data are the blue line. There are some of them that they cannot predict it the same value as the actual data. So there are some of have a large different value. As we can see from the 19 January, there are such a big value difference between the actual and the prediction that I have got. So these are the plot performance of an model 1. So the best validation performance is at 4717.9907 at epoch 13. And then for the AM model 2, I have using 7 input and use 9 hidden neuron and 2 output at the output layer. So the input is the mean temperature, relative humidity, wind speed, cell temperature, solar radiation, short circuit current, and open circuit voltage. So the output is the voltage and current output. And then these are the graph of the voltage output. As we can see, they are nearly the same. The value are nearly same, and as we can see from the graph, they are not separate, and they are in the one line. So it was such a good result that I've got. And then these are for the current output. It's the same as the voltage. We can see there are no such a big difference such as the solar radiation prediction and the based on the value of the prediction and the actual that I've got from the AM model. And then these are the plot of performance. So the best validation performance is at 0.0016786 at epoch 18. And then these are the regression plot. As we can see, the error value for the training, validation, and test are 1. So when the R value are nearly 1, the value of estimated was nearly the same as the actual data. And then next, these are the power output. So based on this, we can see there are no such a big difference between the actual and the prediction. And then we can see that the power output for 20 January are the lowest one. And this we can see that the solar radiation also have the lowest value at the 20 January of 2019, as we can see from the graph for the solar radiation prediction. And then these are the MSE, MAPE, and the RMSE. So MSE is the mean square error, and then MAPE is the mean absolute percentage error, and then the RMSE is the root mean square error. So we can see the mean square error for the train process is 0.000002, and for the mean square for the test process is 0.004, and for the error value is 0.99, and R square is the 0.9998. So we can see the mean absolute percentage error for the output voltage is 0.0009, and for the output current is 0.003. So based from here we can conclude that the percentage of the accuracy is 9.9999 for the output voltage and 9.97 for the output current. So this gives such a positive result for the artificial neural network, and this shows that the artificial neural network can predict well for the AAM model 2. So for the conclusion, the AAM model 1 developed well, but the estimation value does not fit the MLP's theory, which should get regression near to 1. So as for the artificial neural network model 2 stand for the relationship between the environment vector and the PV output of the solar module. To be concluded that this research has successfully met the objective that have been mentioned in the chapter 1. That's all from me. Thank you.